19. Yes.
So why can't we use the mammal or apply? Like both are almost same, right?
Yeah, you can use apply as well if you want to.
The only difference is like passing an array as a second
Second parameter.
parameter,
Yes. Right? Yes.
Okay.
Yeah. Yeah, but here I have only one argument, so call would work. If I have a lot more, I can use apply as well. Or a lot of people would do something, as I said, if I have, args. We haven't really covered call, apply, and bind, which we'll do today, but this will convert array to arguments. If I want to use all arguments, then I would just use apply here and then arguments like this. Okay. Okay. So today let's start with a very important, I think this probably the most important topic in JavaScript, and it's called closures. How many of you know closure? Or at least very well?
Not very well. From your videos, it's nothing but functions with preserved data. I've seen your video.
Okay.
I understood that one.
Okay.
Maybe it is called function that return functions.
Okay. So the first one is correct, but so I think if you go for any interview, and I am literally, I would say 70% of the interviewers would ask this question: what is a closure? Or they will have an example with some sort of closure. Okay, so it is extremely important to understand closure. And also what happens is that if you JavaScript is almost like 80% functional programming and maybe 20% object-oriented programming. Let's say if you look at React or Angular, it's mostly functional programming, and maybe 20% you have object-oriented, where you have you use classes, right? And it does mix of both. So I think it's important to understand how closure works in detail. So in the very first class, we looked at the lexical scope. Remember? Do you know what lexical scope really means? Anybody?
If a variable is defined in the bracket, it should be available in that scope, not somewhere else. Like it's also nesting is also possible. If there's another object inside of an object, it should be available in that.
Okay, so it's basically lexical scoping, which means outer scope. You are using variables that are defined in an upper outer scope. Okay, so think of it this way. Let's say if I have let I equal to 1, and then I can create some sort of a function. Let's say const func equal to, it's an arrow function. Okay, now if I console log here, I don't have actually I inside this function, correct? So the way JavaScript works is every scope, now this is a function scope, but it's also a block in a way, right? So it will, when it scans through the JavaScript, it will first look at all the variable defines inside. So here it would not find any I. However, it will find I outside, right? So it looks up in its upper scope, and let's say if it cannot find it, it keep going up and up until it reaches the global scope. And if you cannot find I, then it would just print undefined, right? But if it finds I, then it would use that I here. Okay? And this is called lexical scoping. So then you don't have to pass all the variable inside a function. It automatically available to you from outside. So you only pass things that you really want to for temporarily, right? Now, why do we use lexical scoping? That is, as I said before, it's you can have lots of variable outside, and you want to have access to them from inside. But that makes your function non-pure. Do you know anything about pure function and non-pure functions?
No, Helen.
Okay, so pure function is if I have const add and I have a and b, right? And what I'm going to return a plus b. This I would call it a pure function. And you can see the difference between this function and this function. This function's job is to, well, I should say, it's the adds function job is to get some arguments and only use those arguments inside the body to return something. So it does some sort of transformation, right? So the result of add function is always predictable. So if I pass add 1 1, I would get 2, right? I can keep writing this many times, and every time it would give me 2. So it's very predictable because it only uses the things that I pass to it, right? So its result is predictable compared to this function. Let's run it, right? Let's say if I run this function, I would get 1, right? Now let's do this. Let I equal to 2. Well, I should not say let again, but I equal to 2, and then I run this function again here. Now this time I'm using, it's the same function, I'm running the same way, there's no arguments here or here, right? But it produces a different result. And that is because it's using something from the outside world. So when you use something from the outside world, it's no longer predictable because it depends on things from the outside. And things from the outside could change, right? And so that's the main difference. So this is a pure function, and this is not. But that doesn't mean that there's a good or bad thing about any of these. They both have their own application, right? Another thing to notice is I am not setting anything to the outside variable as well from here. A pure function are just like really just functions that has one and one only job: to take the argument, do something with it, and return something. A non-pure function could set something somewhere else. It doesn't have to even return anything. um, things like that. Okay, so when you're using a non-pure function, um, one of the problem in this kind of design is that there are times when functions don't stay in its own place, right? Because I have defined it as a variable, so I can actually pass it to another variable. Now its scope has changed, right? So when I execute it, it's actually somewhere else. So let's look at an example. So what I'm going to do is, instead of let, I'm just going to use a const to define this function. And then I'm gonna say if true, which means always run, right? And then I'm gonna put this function inside here. And this time I don't have to use const because I already defined this function here, right? Now let's put this I inside the scope. Okay. So now if you read this function, what's really happening is I have defined, do you know why I defined with using let? I can't use really const here. And that is because if I use const here, it will not let me use equal sign again. Because this is technically like equal to undefined, right? It won't let me use the equal sign. So I have to use let. So what's happening here is that the scope of this function is actually global right now, right? Inside this block, I have a variable I equal to 1. And so its scope is actually only between the boundaries of these two curly brackets. All right. Now, because this func is defined outside, I can run it outside from here, right? If I console log I here, what do I get? Do you know what would I get if I console log I here?
Undefined.
Yes, because it's not available outside here, right? So if I run this here, it doesn't, when it's defined, it's using I, but when I actually run it, it doesn't, I is not even available here. So let's run it. Let's see. What would I get here?
1.
Yes, that is because of the closure. So let's understand what really happens. So in JavaScript, because a function can move around outside their scope, it doesn't really make sense. If it moves around, you lose that lexical scoping advantage, right? So what function does, it actually holds all the variable it needs inside the function. So even if it moves outside, it can actually use it. So if I just simply console log this func here, well, I have to do dir. I would see this scope here, and inside I would have a block and global, and the block I would have I equal to 1. So that is how actually it preserves this. So basically what function does is, when the JavaScript scans a function, it instantly figures out that it's using I here, but the I is not present here, right? So what it will do, it will find the I from the upper scope, and then it would preserve inside the closure. That's all it is. This is in nutshell. So basically, you see the scope. Scope is nothing but what this function can use, right? And it has two. Yes, it can use anything from global or anything from the lexical scope, right? So this, it preserving its lexical scope inside this function. Got it? Any question on this? I think it's very important to understand this so that, well, I'll give you more examples, but this is the definition. If an interviewer asks you what is a closure, this is how you describe. You can say JavaScript follows a lexical scoping, which means a function which is non-pure can access variable from outside its scope and use it inside. But in JavaScript also, the functions can be passed into another function or can be delayed and all that things, right? So when that happens, that lexical scoping is not really available to it because it's not inside the scope that was defined when it really executes. In that case, it needs to preserve all the lexical scope um, inside the function. Okay. So what it does, it knows what it is using. Here in this case is I. So it preserves I inside this function. Now if I have another variable here, let's say let k equal to 2, right? If I run it, if you look at its scope, it doesn't have k inside because it doesn't really care about k because it's only using I. But let's say if I add another console which uses k and then run it, then it would hold both. So it only holds the things that it needs to run this function. And that is the closure definition. Um, if you look at the web, most of the places they say closure is an inner function. And you can see it's not true, right? Because there is no inner function here. Um, a lot of people, I haven't actually gotten a very good explanation. I had to figure out myself that this is the case, right? Because if there was no closures, I cannot really do this way because this function will return undefined. Then it's useless, right? This is a little weird case, but I'll give you a real case where um, it makes sense. Okay, so let's look at another case. Um, all right, so let's have a function equal to, okay, and remember you were saying about the inner function, right? So let's have an inner function. So inside this scope, I have let I equal to 1. And what this function is doing is it's returning an anonymous function. Okay, and all it's doing is this console log I. Okay. So how do I run this function? So for example, if I execute this function, what would I get? I would get, all it does is it returns this function, right? So I can say let inner equal to this, right? And then I can execute inner, correct? That will execute this function. Now, again, the inner doesn't really have I, right? Because I'm executing outside. But because of the closure, it would hold this I inside, and when I run it, it gives me 1. So this is an example of inner function. So as you can see, it's not really, closure is not inner function. Closure is a variable that is stored inside a function that it's using from its outside of its scope, right? I can also run this function. I don't have to do inner and all that stuff. I can simply do this. And it gives me 1 as well. Do you know what is happening here?
When you say function bracket open close, it's returning a function. By
Yes.
using another bracket close, you're executing it.
Yeah. And this concept is called currying, right? Because you're running one function that returns a function with closure, and then you can execute the function again. So for example, let's say if this was my add function, and let's say if I have a here, right? So what it would do is a plus b, right? So if I do 1 and 2, it should give me 3. Oh, funk, did I change? Oh, that gives me 3. This is called curry function. And you're going to be using, I mean, if you use React, there are lots of curry functions. So that's why it's important to know closures.
Hi, Hema.
Yeah.
Yeah, I just saw an online definition for currying. It means like creating a copy of the copy of function, right? But you're not copying a function here.
Copy of the function.
Yeah, function currying means like it's creating a copy of the function with some present parameters. So, but here you didn't copy a function, right?
No, there is no copy. Curry means, um, uh, to look at the history, there was a guy named Haskell Curry, and what he did, he created a language called Haskell, and he first introduced this concept of, um, I believe he introduced the concept of closure in the language itself, right? And he did this by, you know, you pass one parameter and it holds, and you return another function, and it holds the first parameter inside. And so when you execute the second time, you will, I can actually keep returning and returning, right? And I can keep doing this. So that's the curry.
Okay.
Yeah. There is another thing called partial function. I'll give you, yeah, I have another example. I don't have it right now, but I'll give you next time. But it does something similar. Okay, but you guys get this concept, right? How does this work?
Sure.
Okay, all right. Um, another. So, do you can you think of any other places where I would need to use closures, where I define a function in one place and I'm using it some other place? Okay. Um, when you do something asynchronous, so like example, let's say I have a for loop, right? And let's say if I have a function inside called print, okay, and it just prints something, right? Now, what would happen here? It's still not asynchronous. So if I, well, I have to execute it again, right? It would print 1, 2, 3, 4, correct? Um, that is because when it loops, every time it gets a new variable, because it's an let, every time this function runs, what happens? You get a new variable called I equal to first 0, second time it's 1, 2, and 3, right? So when this print function is defined, it has a closure I, and then it right away executes it. Then again, so every time this print is a new function, it's actually creating a block scope inside every time. Got it? Now, what if I say, instead of running it like this, if I put a set timeout? Do you guys know what set timeout is?
Simulate asynchronous behavior. Maybe we can introduce some delay of some millisecond.
Yeah, so let's say if I introduce a delay of a 1 second here, okay? So what really happens now is the for loop would create I equal to 0 first. It would go inside here and it will um, have this function, which is an anonymous function, and it knows now that it won't run right now, right? So it will set I equal to 0 as a closure here, and then this would run again, and it will create another function with closure 2, another function with closure 3, like that. And after the for loop is finished, for loop finishes first, then your event, so there'll be like a four distinct functions that are waiting for it to be executed, right? So then the first function would execute after this, after 1 minute delay, and then second one and third one. Oh, 1 second delay, and then second one and third one, right? And then fourth one. So if I run this, it waits 1 second and it'll print 1, 0, 1, 2, 3. Correct? So because of this closure, even though it's no longer inside this for loop, right? Because when it's really execute, it's not inside a for loop. You have to think about that way. When it sets timeout, it creates a function and then say, okay, I'm gonna make this function run once the entire page is loaded. So once this for loop and anything after this is executed. So if I have, let's say if I have a console log after, right? Oh, somehow it's not running. Then after run first, and then 0, 1, 2, 3. So you already know that these functions were created with the closure inside. If there was no closure, asynchronous programming won't be possible, right? Because this function uses I from outer scope, because a function doesn't really have its own I. Okay, so now we come to a very tricky interview question. An interviewer would basically change this to var. All right, anybody knows what would happen here now?
Maybe in the block scope it has 3.
Say it again, block scope.
The I value is 3, so it prints 3 in the console log.
So, okay. So all threes?
I believe so.
Okay. Yeah, why is it printing 4? That is strange.
Because the I value is 4, like after the last.
Right. Yeah. Why is that?
Because the follow-up is ran like 4 times and the I value is like 4.
Mm-hmm.
But when you actually call the function, the I value is 4.
Okay. So what's the difference? I mean, when I use let, right? It was giving me 0, 1, 2, 3. When I use var, why does it give me 4? That's my question. They're both for loops, right?
Let has the block scope, so stays inside the function.
The var stays inside a function as well. So, okay, let me give you an example. Let's say comment this out. If I do console log I, what would I get?
0, 1, 2, 3.
Yes, right? But with this, I get 4. And this is a very important interview question. I would say nowadays, pretty much everybody's asking this question. So you need to really understand exactly what's happening. You can give a solution. Yes, the solution is if you change it to let, it would become 0, 1, 2, 3. right? The question is why. So for that, you have to really understand what's happening here, right? Um, so think of this way. Um, it's all about closure, right? So because var is a function scope, it's actually not, when I do var I, it's not actually creating a new, for this, new variable every time. Let would create, because inside, remember in the first class we learned that if you have a block scope, if I have two variable with the same name, it won't, you cannot have it, right? So you have to create a new variable. So let's say if I have let I equal to 0 and let I equal to 1, let I equal to 2. I cannot do that because you cannot redefine, you cannot use the let word again, right? So in the for loop, what happens is every time I is created, it's completely replaced by the new I. So it has a for as if, so it would have something like this, because so this is the first loop. After the first loop, this is after the second loop, third loop, and for loop, right? 1, 2, and 3, and there will be the function right here. Right? If I have a regular function, then it would be like, okay, I have first I, let's do this. It would print 1, 2, 3, and 4. Or, sorry, 0, 1, 2, and 3, right? But if I have a timeout here, then it would close the I equal to 0 here. Then again here, it would close I equal to 1, 2, and 3. Right? Now let's look at var. What happens to var? Var is a function scope. So inside this loop, it doesn't really recreate the same variable. So let's say if this is var, then it would simply do this. It's the same variable that reassign a different value again. Right? And the last one also, there will be like I plus plus, so it will be like I equal to 4. Right? So what happens in this case? Closure, it only cares about I, holding I inside. Now here, the value of closure changed. First it was 1, 2, first it was 0, 1, 2, 3, and now in the end it would be 4. Right? So what it would do is it would close the last value. It's actually doesn't, it's actually reference, right? So in all 4 closures, the reference changed to all to 4, right? Because it's only one variable. In the other case, I have 4 distinct variable, So it creates four closure with four distinct variable. Here it's only one variable, so it creates a closure with one variable, which is four. Make sense? I
So
90% of the I'm actually spearheading the interview process for my company right now. So I do like a 2 3 interviews every single day. Um, and I ask this senior engineers, like somebody with 10 15 years of experience and at least JavaScript experience of past 5 to 10 years. um, when I ask them what is a closure, mostly the answer is, oh, it's an inner function. So I say, can you so then I put here this example. I say, where is the inner function here? This is not an inner function. Inner function is a function inside a function, right? Now, there is no function inside a function, but there's a closure here. They cannot explain it very well. Um, this example I give them, say, okay, how to fix it. Some of them know that because they have actually done some tutorials, they can change let equal to I and all that stuff, right? And they say, oh, this is how it works. So I said, can you explain to me exactly what really happened? And they say, oh, it's because of the closure. I said, okay, because of the closure, but can you explain in detail how exactly it works? And they cannot explain it. That is because they don't really understand how it works. So um, you need to actually go at a level exactly for each loop what's happening. And as you can see, the difference between let and var is only one variable. It just changes its value. Let is every time in the for loop it will create a new variable, and that is why every time it would hold a new variable inside that function, right? um, and that's the trick. So this is a closure for you. You can also use this in, I think if you use a promise, also the same thing, right? Anything that is asynchronous where your defined function is no longer exist, um, then you have to, it will create a closure. Okay, any question? Yeah, I wanted to spend really long time on this so that it really goes in your head, because if if you can understand closure, you can, you know, functional programming becomes very easy because you understand underneath how things work. So you can actually solve a lot of problems. Let me quickly get some water and I'll be back. My my throat is a little bit um, dry. I'll be back in 2 minutes. All right. So, um, oh yeah. So another thing I wanted to say on this topic, the reason that let me. So here, um, what happens even in this case is that when you have a closure. So let's say you have this function, right? So the function, there are four functions are created. Okay, so there's a function one, and let's say it has a closure. Let's say we're gonna call C. So when this function was created, it would point C to I, right? Which is this. That's a C equal to I. Now the second function is created. It also does C equal to I, right? Um, but here I became 1. So the reference, because it's the same variable, the reference is the same reference, right? So this I become 1, this I become also 1. Now again, the same thing here and here, right? So when I goes through different values, all four functions would have a reference to this I. And usually what happened, ultimately this I would die, right? Because after this for loop, it doesn't exist. And at that time, it actually creates a closure because when it cleans it up, its reference gets preserved inside the closure. So ultimate I equal to 4. Compared to when you have a let, because there are 4 different variable, um, just like let's look at 2, right? So this I is this I, this I is this I. Because there are 2 different variable, it has 2 separate the references, right? So this is 1 and this is 0 and this is 1, and this would be 2 and 3, and there won't be any 4, right? So yeah, so this is the nutshell how closure work. All right, so let's move to the next topic, which is call, apply, and bind, which is like another very important topic. If you go for an interview, you will have at least one question on closure and one question on call, apply, and bind. If the company actually are looking for a serious programmer, I usually ask one from each. And if the interviewer cannot understand, I don't really care if, I mean, if they understand a little bit of closure, then it's fine because it's very tough. A lot of people don't even know it very well. But if they don't understand call, apply, and bind, then I don't really hire them because I feel like you don't understand two main concepts of JavaScript, you should not be working here. Um, so let's look at call, apply, and bind. So another paradigm. So now we are inside the functional programming area of JavaScript, right? Where you have callback functions, closures, and in inheritance you can have, you can create, let's say, mammal, and then you can create marsupial, and then from that you can create an object, right? Call kangaroo or something, right? this is typical flow, and then marsupial would inherit all the properties of mammal, and then you can create, and you can have a nested tree like this ultimately, but the objective in the object oriented is you inherit everything from your parent. Last time we looked at the mix-ins where we do partially, right? We had a Superman. Well, we had a man, and then we had alien or something. I forgot what was or flying man. Flying man or something, right? And man can cry, and flying man can fly, right? So what we did, we said, okay, I want to use some of the man's um, ability and some of the flying man's ability, and I created a Superman, right? So this concept is the same thing. Um, over there, I believe, we used object.assign to do that. And what object.assign does is it copies man's uh, methods. So you create, let's say, Superman using 2, and you can copy some of the men's prototype methods into Superman, some of the flying man's methods into Superman, right? So it's almost like a borrowing some from here, some from here, and mixing it, creating something else, right? Um, but object.assign actually copies methods from one object to another. Um, you can use something else. You can use call, apply, and bind, which also does similar things. But instead of copying, it just it does it on runtime. At least call and apply does. So let's look at it, how it works. Um, let's look at a very simple example first. So let's say if I have a const add function, right? Now, let's say I define it something like this: console log this dot a plus this dot b and plus c. So anybody know what happens when I run this function? How do I run this function?
If you're running it, I think it should throw undefined since ABC are not defined.
Yes. So if I run this, they are undefined. Let's say if I do C here, right? So I can at least have C. Now I need to take care of it. Remember, this is not an object. This is a function, right? So it doesn't know what this really means. Have you guys watched my tutorial? I wanted to cover this, but I already created one tutorial on this. Did I cover this keyword? I don't remember. I know we use in a constructor, but did I cover in detail how this keyword works?
I don't think so.
Okay.
A lot ago.
Okay. All right, let me just cover, because that's very important as well. So remember when we did the constructor. So difference between a regular function and a constructor, right? So let's say const create something, right? Equal to, I have a function and I can pass a and b, and inside I can say this dot a equal to a, this dot b equal to b, right? So the difference between these two functions is what? Can somebody tell me? What do you see obviously that there is an obvious thing going on here? Um, the obvious thing is in this function, I'm creating two properties, this dot A and this dot B. Remember we did then, I can create something and I can pass like a 1 and 2. So it would set A equal to 1 and B equal to 2. So if I console log this, well, I have to say let const sum equal to new. I have to use a new keyword, right? And then if I print, so it created an object because create something is a constructor, right? So if I run this, it has two properties A and B that we looked at last time when we look at the object and everything, which makes sense when you use it with new. But anytime you have a this inside a function and you're not using new, like if I do add 1, it doesn't really make sense, does it? Because I'm not actually setting any properties. So it really doesn't know what this really means because it's a function. It doesn't have A and B property because I'm not setting, right? If I set, I have to use a new keyword. But otherwise, this keyword inside a function doesn't really make sense. Okay. But it makes sense in some cases. What cases? So, also, let's look at one thing. If I console log this inside here and run this, what would I get? Windows, right? Means it's trying to get things from outer scope. If I use strict, in old JavaScript they used to allow this, but it's forbidden to use this inside a function and execute it without, it gives you undefined. Before it used to give you error, but now it gives undefined, right? So if this is undefined and then I cannot really get this dot A, right? So even if I did something like this dot A equal to 1 or something, right? If I run it, it says cannot set property A of undefined. Because if this is undefined, then I cannot even set A equal to 1, right? So always remember, if you have a regular function, then this inside a function doesn't really make sense. So how do you deal with this now? I can say, if I have an object, if add was a method of some function, then I can get this A. So if I had an object, So let's say if I have an object and it has, let's say, A equal to 1, B equal to 2, and add equal to add. So I can, if I call it like this, and then if I use, let's say object dot add, then I do, all I have to provide is C now, right? Because it will take A and B from here. So now if I run this, I would get 6, which is correct, right? 1 plus 2 plus 3, 6. So this method has to be attached to some object in order for it to use A, right? Now in this case, I'm just using it like this. But there's a better way of doing it. Because I made this add part of this object, which I don't really want to do. I want to keep the object as it is, but somehow use this method on this object. So that's where the call comes in the picture. So you would say, take the method first, then say call, and the object that you're calling on. And then you have to provide argument to this add method, because there may be some argument like C, right? So here I need 3. So I'll do that, right? So now if I run this, it would get me 6, as if add is part of this object. So I am saying that, okay, I want to use this method on this object. So it's all runtime. This method is not part of the object, but I'm still somehow using it. This is one of the biggest concepts in functional JavaScript, right? You can borrow function from here and use it on here, even though it's not part of it. I'm not adding the add into object, I'm just using it. Any question on this?
Hemant, so call is a method that's available on all constants or any literal?
Yeah, call is available, yes, to any. So okay, it's available to functions, right? So if I console.dir add, let's say I haven't added this call, right? And if I run this, I would get add, and it would have a prototype, and you can see the method call here, right? It's a prototype method. If I do object, because it's not a function, that method won't be available. Oh, console dir. See, this does not have the call method. So I cannot call on object. I can only call on functions, right? Because it's coming from the prototype of a function. So every function, as I said, every function has its own prototype. Every object has its own prototype methods, right? So this is prototype methods of a function. Okay. Now, what is the difference between call and apply? So let's say instead of 3, I would have C and D here, right? Now I need to pass D here if I want to call. So let's say 4. I don't know what's happening here. All right, so if I run this, oh, plus here. Now we'll get 10. So 6 plus 4 is 10, right? Which is correct. But if I have a lot of these arguments, then instead of having passing it like this, I can actually create const my args or something. Okay. And I can have 3 or 4, right? And then instead of call, I would just say apply. And instead of 3, 4, I would have my args. And it would give me 10. Any question on this one?
So basically they're similar, except the apply we send in arguments in an array format. Is that it?
Yes. That's the only difference. Now, a quiz question. How do I still want this array to be here, but I want to call here. What changes do I make?
Can you repeat the question?
So remember, apply takes an array, right? Call takes arguments. Now, I want to keep the arguments in an array like this, but I also want to use call instead of apply. What changes do I make here so that it would take an argument here?
Spread operator?
Yes, because what spread operator does, it converts array into arguments, right? Remember we looked at the spread operator. All it does is basically this into sort of like 3, 4, right? So now it would take an array and it would spread it. All right. Any question on this? Because this is kind of very important. If you understand call, apply, bind, and closures, and there are a few other things, you kind of master and then the callback function. Remember we looked at earlier. You kind of master the function programming in JavaScript. Okay, so remember we looked at the last time the example from here, from Sesha's homework. We had this. right? Let's remove the prototype. We don't need prototype. We just need this. So what's going on here? We're using call function, right? So now think of, so this is also very important to understand because mammal is nothing but a function, right? Technically. And when you use it with new keyword, it becomes a constructor. Same thing with a marsupial, right? So now I want to call it super. And what super really does, it basically sets all the properties that the parent superclass did, right? All it needs to set is this dot legs equal to leg, correct? But I want to use it on this object. So then this should have this dot legs equal to legs, right? So if I want to do that, if I take mammal, which is a function, which has a call method already available, then I call it this function. So instead of setting this leg here, it would set in this function, in the marsupial, and its arguments. So argument is nothing but, well, not arguments, I would say legs here, right? Now it makes sense? So this is one utility of call function. And you would be using, I think call is one of the most important function because you'll be using a lot in functional programming if you use React or Angular. Not so in Angular, but yeah, React you'll be using a lot. Um,
So, Ahmed,
yeah.
just to get a little more clarity, I understand if you do mammal call this legs, we get this dot legs equals to this in marsupial. But what exactly is happening when we are sending this and legs to mammals call internally?
Basically, as I said, it think of call function is you have some function, right? Which is this. It doesn't really have. It needs in order for mammal to be uh, to run because it doesn't have this context. Um, this when I call it on this of a function or this function, is basically sets it basically it's almost like it just does this, right? So instead of so the which context you're calling on it that changes, right?
Okay.
So instead of this which was here, now it became this here. Now here it's setting it, but in the previous example we were calling it, right? What's the previous example here? We are actually calling the um, add, which actually console logging it, right? So we're not setting anything. In the other example, we are setting it. Okay. Um, Another utility of argument, should I say, I mean call and apply is, let's say if you have um, a function equal to function, and remember each function has an argument object. So if I call this function 1, 2, 3, I would get some arguments inside. So this is, every function has this object available, property should I say. And if you look at it, um, it's not an array, by the way. It's an array-like object because it doesn't have a prototype uh, that allows you to, it has an iterator, but it doesn't have any, it has a length and iterator. So you need like other methods, right? That array has slice, things like that, right? Which it's not available. So what I want to do is I want to create this into a regular array, right? So what I can do is I already know there is a slice method available. Where is it available? If I take an array, an empty array, and if I look at its prototype, well, I have to say slice, and I have to say prototype. Okay. So I want to call this method on arguments. Okay. So I took a method from arrays prototype and I'm applying onto this other object called arguments. If I console log it, now run this thing. Okay, now I'm getting an array. Well, something got messed up. Oh, I need to have a call. So now I'm getting an array, and this time I have a prototype which has all the concat and everything. This is quite useful. Another application would be, let's say, for apply. Okay, so let's say if I have an array, and it has a bunch of numbers. Okay. So here 12 is the maximum, right? And I want to find the maximum number here. Right? JavaScript has a math library. So if I console log math, it has a min function and a max function. So if I look at it, there's a math library with a bunch of functions, and one of them is max. But the way max works is actually, you would say, let's say console log max, math.max. And if I do like a 1, 2, 3, then I have to pass arguments and it would return me like 3 here, right? So it returns me 3. But here I have an array. So how do I utilize this max function on this array? So I get back 12, which is the maximum. Anybody knows? So remember, it's an array, so we can use apply. Or we can use call as well, but let's use apply. The first argument always, first thing is always you need a function that you want to apply on some object, right? So I'm going to say math dot max and then dot apply. Okay. Now I know that apply, if I pass array here, right? I'm not really setting anything like to this, right? So all I have to do is null here. So as if I'm running this max function and I'm just converting this array into arguments. Right? So now if I console log this, and let me remove all of this, I would get 12, which is the maximum. Right? Well, nowadays you don't even have to use this. You can simply do this, right? Max.
I think we can use spread out also, right?
Yeah. Right. So that's what I was gonna say, that you can use this also. Okay. But before ES6, we used to use that way, apply. That does that. So, oh shoot, I'm okay. I didn't keep track of time. All right, so let's do one. Okay, so we still need to cover bind, and let's stop then. I wanted to cover the SAS, but I think these two topics are so important. I thought, okay, so let's cover bind. So the difference between call, apply, and bind is call and apply executes, so takes a one object, takes a function, and it treats them like it's a part of this function, is part of this object, and you're running it, right? Bind, actually, what it does, it takes the one object and a function, and it combines them and it creates a new object. So let's go to the first example where we did that, right? So I don't have to type. Okay, let's look at this example here. So I have an add method and have some objects. So here it just calls it and gives me the result. Okay, so the result is some number, right? Now, let's change this to bind. Okay. Let's say 3 and 4. So, as I said, bind actually combines them and gives you a new object with that method, right? So if I console log it, let me use dir. You see the function, then it says bound add, which means this function is bound. You don't see like object with method and all that stuff, but you would have these three things: target function, which is this add, bound this, is the object itself, and then arguments, which is this. So it separates the three things. It doesn't like clearly give you another object like this, but instead it has this special function called bound function, which has function which is bound, which is you binding, the object you're binding to, and then the arguments you're providing. So let's say if I call this const bound add equal to this, right? Now I can say bound add. If I just execute, what really happens? It gives me 10, right? As if I just preserve this function. Now, what if I do 1 here? What would happen? Let's run this. Huh, nothing, right? Because we haven't actually defined anything. Because it only takes 2 arguments right now, right? But if I have something like e hold on. Oh yeah, I need to. Then it gives me 11, right? Because then it already has 2 arguments that are preserved, C and D. And so when I do this, it takes the next argument, which is E. Now again, you need to get used to all of this, so that you can you can think in this sense, right? You need a lot of practice. I think or closures call apply and bind. If you don't use it, you lose it. Like 10 days later, I'll ask you how the bind works. You might have some concept, but you won't be able to code it, right? So that's why I would suggest, use this um, in the real application, do a lot of coding, create a project where you can use this so that you understand the practical application of it. Okay, now let's look at this is more like to example to understand, but let's look at another application. Any question on this, by the way? We use quite a bit. I mean, in JavaScript, bind is quite a bit. I'm sure you've seen it, right? Um, just think of it as you take some function and you take some object, and then you combine them to create something new. That's a bind. Okay. Okay, one of the example I would say is, let's say if I have some button, which is a function, right? And it has some content that you provide inside. and you can say this dot content equal to content. So this is our constructor, right? And then I can say button dot prototype dot click equal to a function that basically say console dot log this dot content plus, let's say, clicked, something like this, right? Okay. Now if I do this, let's say let my click equal to, I can actually take the button and click. What does this do?
Undefined clicked.
No, you would have, no, my click would have the, yes, if you execute the my click, you have to execute this. If I do my click, then it would be undefined plus, well, my click is not a function. What?
Spelling mistake, line 9.
Ah. It's not a function. My click function. My click is not a function.
On line 9 should be execute button.
No, sorry, it has to be my click. It's just an object, yeah. It has to have a click, right? What it's saying is yeah, as you said, click of undefined, right? Because it doesn't really know this content. How do we solve this?
By binding this to click function.
Yep. So what I would do is take so instead of creating it like this, I can do this. Let my new click or something, or bound click equal to, I can take button dot click dot bind to hold on, my yeah. And so now if I do my bound click dot click. Okay, hold on. Just did I make some mistake here? Okay, let's see. Oh, then I don't know how to do it. I just do. Then I just execute this function, right? Because it's already bound to this. Okay, maybe I made some mistake here. Let's see. So I have a button dot click. Okay. Dot bound to my button. Oh, button. And then to this. Oh, I need some content. That's. Did I provide some content? Do you guys see the problem somewhere?
What if we bind this to online level? Button.click.online.
This? No, this is a window, right?
Oh, okay.
Yeah, you cannot bind this. If it's inside, I can understand. So binding to button is almost like binding to this button, right? Let's see what the problem is. You know, the problem is I made a huge mistake here. This is a constructor, right? So you need to create a new button. New button equal to new button and some, let's say you say new button. Okay, that's the problem is because until you do that, we need to create after this line because after it sets a prototype, and then use new button to, and this should give you the yeah. If you just put some space in here. Because you need to create an object, which this is a constructor, right? Because we are never running the constructor. Either you do this or you create an object and then you run a constructor. So you don't do this high because high doesn't have any meaning here unless there's some other argument, right? So if you look at the bound function here, console dir my bound click. So you have a bound function. The target function is the prototype, right? Bound this is the new button, which is the content, and we don't have any arguments, right? Because we didn't pass any arguments. So that's how it works. This is also an interview question. I've been asked this question a few times. So basically what they will do, they'll create a button like this, and they would say they would extract the click from this when you extract the click, it doesn't really have then, it's not attached to this um, object, right? So you have to do this to attach it back to the object. So now you have bound click instead of just my click, and then run it. That's the answer to that question. Um, okay. Any questions so far? Any uh, any problem with the homework, guys?
Not yet, Hemel. I just started a React app building components.
Okay. Um, because it's time that you can use this. So how about a build that app, at least build the first app, okay, and then we can do something with it, because I think I feel that this kind of call, apply, bind, closures, things like that, you have to really use it in a practical world. Otherwise, the knowledge will go away really fast, right? um, One idea I would suggest is, and I mean, it's up to you what you guys want to do, is we can create like a small game, okay, um, where we can use all this functionality, um, and because I feel that games are much simpler to design, but you can use a lot of logical stuff rather than user interface where most of the time you spend in like HTML and CSS rather than the core logic. Okay. Um, but I think the first objective is just to get that, you know, just build build just your first app using React, and you will get to use like, you know bind and all that stuff over there, and then you'll understand. Oh, this is how you use it, right? Um, yeah. Um, Another thing. Remember, we did this. Uh, so we have. Let's say if you have a function that. This is another interview question that I ask my candidates. Uh, and I'm going to ask you, let's see if you can solve this. Okay, what do I get if I run this?
Maybe undefined.
Yes. Why?
If we bind this to get A, maybe we'll get 1.
Yeah, so one way to do it is you have this inner here, right? So inner can be replaced with the bound function, right? So you would say inner dot bind this, right? That's a one way of doing it. Another way of doing it is make this an arrow function. So then you don't have to worry about um, it uses the get ace, right? Um, Another way to do it is using and then you can call something like that, and here you would simply use this, right? So there are many ways to do it. But you would be using the bind more because in React, um, see, also another thing is this. What do I get here?
One.
Yes. What if I want to use arrow function here? What do I get here now? Undefined, right? So here I can also use bind because um, right, x dot get a dot bind x. So if you use a React classes, you would use a lot of methods like you want to use an arrow function, but then when you use it really, you have to bind it. Because the good practice nowadays is not to use like a regular function, and you need to use an arrow function, right? So um, that's the another application. So yeah, I mean, you need to practice this a lot, um, and that's the only way I would say you can use it. So what do you guys think? I have a proposal. Um, since we're doing the React app, I was thinking we can build a small game. Okay. What do you guys think of? So the game would you can finish the game in like a couple days. Okay, but you can use arrow functions, closures, call, apply, and bind, um, spread operators, all of that, and then we can you can make it a personal project and add more functionality. You can convert into, if you want to do like a React Native project, so you can build your own little um, mobile app or whatever you want to do, right? What do you guys think of that?
Maybe something that involves in exploring complex JavaScript projects like classes, inheritance, call apply bind. I'm interested to work on any project that involves or
Yeah, so
includes
if you
this.
use it, that's what I like it. So React, if you have a React project, you would be using a lot of complex inheritance. You would be using prototype. You would be using call, apply, and bind. You would be using spread operators. Um, yeah, all of that. I mean, I do I in my current project I use a lot of that, right? So that's why I'm thinking, and I can. There is a game that I came across. It's a simple game, um, and I thought it would be very interesting to build that. Um, so let me. And you can suggest some game. I'm just this one game I came across, which don't look at the solution. You can build in a pure JavaScript as well, or React, whichever. I'm okay with it. So all right. So let's say this is the game. Okay. Uh, well, actually, not this is like a little bit complex.
Hello, YouTube.
Okay. So let's say this is the game, right? And so what happens here is that I think this guy made it, but don't look at the solution. Just look at the requirement. Um, and so the way it works is simple. When you have these four quadrants, right? Four colors basically, and it's a memory game. So you have to remember a sequence of colors. So for example, when you start the game, what would happen is one color would flash, and then it gives you a chance to reply. So let's say green flashed, then it's your chance to actually do the same thing. So you click on the green. Um, if you're correct, because the green flashed, you get to the next level. But let's say if you clicked on the red, then you go back to the zero because you failed, right? If you are successful, then next time it will do the same color first, green, and then maybe some other color like red. Then it's your chance to do that. So you tap on green and red. Then if you're successful, it will do green, red, and maybe another green. So then you click on red, green, and green. So every level you have to remember one more color with the previous colors, right? Um, so it involves a lot of things. For example, you have to remember the state of the project, right? You have to remember. You have to do like a click event here, right? Um, you have to here kind of think it's more. It also becomes a little bit asynchronous because it does something, then you do something, things like that, right? So it's big, and then you can actually create a server, a backend server that remembers the scores and things like that, right? So you can say, okay, the maximum score. So you can use a promise there also. Um, and yeah, so think of this way. If you can watch, don't watch how he develops it, but just watch. I think there's, I would say understand the requirement, and then we can discuss it next time. Um, the name of the game is called Simon Says. Simon's Game or Simon Says or something like that. Okay. Um, so independently, can you guys come up with the requirement? So can you draw a flow chart of things that are happening in this game? How would I remember the state? So the simple requirement would be uh, you can play the game. Then if you can remember the all the scores that you have done. Like, so if I've played 10 times, then I would remember all the scores that I've historical scores. Um, and then I can also look at the first five oh, five max scores that I've done. Okay, and then you can put some dates with it. So you can save the scores with a date into some sort of server. Okay, again, this can be built with pure JavaScript. I think it's possible. It's very easy to do, or you can use also React to do it. But what I want you to go through is a requirement process in terms of understanding what's given to you, breaking down into what you need to do. So you need to also figure out how to do CSS for this. Um, you also need to do, draw a circle within a circle. That may be a little bit complex, but you can figure out. It's not that difficult. You can use a z-index and whatever you want, right? Um, so what do you first? What do you guys think of this one? I mean, if everybody agrees, then I think we can go about it, and it will take about, let's say, 3 sessions to finish this game. And you work on it independently. We just discuss your progress. We don't really design the game during the class. The class is to just learn things, and then we half hour or so we discuss the game and what your progress is, what are the difficulty requirements, and whatnot. So what do you think, Sesha, Rama, Indra?
Hemal, I think this is a good idea. I think the first step is to identify requirements and trying to break it down into sprints or manageable chunks for each week.
Okay.
I think once that is set, we'll get more idea.
Okay, Rama, what do you think?
Yeah, I'm also with you. I can even start working on it today.
Okay, and Indra? He went to sleep. Okay. Okay, so let's do this, right? Um, I don't want. I just gave you a basic requirement, and I'll type it what that might be, right? Um, and then you guys can um, break it down into detailed requirements, like what you really need to build this thing. Um, in terms of HTML side, CSS side. If you're using a React project, then you need to do that way. If you're using pure JavaScript, then you need to also think about what elements do you need. Then in the JavaScript world, you need to actually look at the overall how you're gonna manage the state of the game, right? When you from the start, what do you need to load? Okay, you need to show like the maximum score, right? You need to show so you need to initialize. You might, I mean, right now, let's just you have only one user, so we don't remember the username. We just remember the number of score that this user is um, has achieved, right? So every time you get to a new level, you would basically have a score that you actually added to the game. Okay, something like that. So yeah, and then you might require some backend also, and you can use whatever the Spring Boot um, or you can just load it locally. You know, if you don't want to build a backend, there are a couple of options also. But just also think about the backend, how it's gonna look like. So that you need to, because we're gonna look at the promises and all that stuff, right? So you need to think about how to get the score and load it when the user first loads the game. Okay, there might be some user interface. Um, so here I have a start, and you can actually read that. We don't really have to follow exactly this kind of format. We can have colors, splatter. You can follow exactly this design if you want to. You can have some scores showing up on the side. Okay, um, stuff like that. But that's a minimum requirement. Score display and the current status of the game. Okay, so think about it. You can build a document. That would be the homework to come up with the requirement and essential things that you need to build a requirement. And you can actually even start if you want to. Okay, for next time you can make as much as progress as you like, and then we can discuss if you're going in the right direction and a wrong direction, right? I think that's fine. If you know, if you made a mistake, that's fine. We can come back and correct it. So next, we'll take some time next class to evaluate the requirements that you come up with, and we can look at all the components that you need to do. And if you're using React, then you can divide your page into smaller chunks of component. If you're using pure JavaScript, then you need to build some sort of a library of functions and stuff like that, right? So feel free to choose either or both. Okay, React would be much easier, but I think because it's not that complex, pure JavaScript would work as well. Okay, sounds good.
Yes, Hemant.
All right. Um, right. Yeah. Let me know if you have any questions, and do practice call, apply, and buy, and also learn closer. But I think in this if you do this, you get to use it. And that's my concern, that I don't want you to just, like learn this stuff and next week you come in and you learn something new, but you forget something that you learned previous lesson, right? Which is not a good idea. So you need something to build that continues with you. And you can actually, in future, you can keep improving the game, right? You can add multiple users. You can actually change the strategy of the game. You can change the game itself and add more complexity or whatnot, right? Instead of 4 colors, you can add 50 colors. I don't know, whatever. Okay, so that's a fun part of this thing. All right. All right. So I think let's do that next time. And then next time I want to spend most of the part in CSS. I want to cover. We started the SAS last time, so let's just start with SAS. We finished the SAS, which would take almost whole lesson, and when we'll review the game. So we just take a break from JavaScript next time. Okay. All right, guys. See you next Saturday then.
Thank you.
All right. Okay. Bye.
Have a good weekend. Bye.
Have a good weekend.
All right. Have a good weekend, guys.